Welcome to the Math Record. Today we'll be answering the CCML Algebra 1 Contest to 2015-2016 Division A. Okay, question 1. 6.4 minus 9.2. You could just write this as 9.2, 6.4, and then you kind of minus them together, so that makes a 12, and that's a 8, so that's 2.8. And then you just put a negative in front of it because 2.8 is less than 9.2. So the answer is negative 2.8. Basically that simple. Question 2, solve for y. You have 2y minus 8 is equal to negative 3y plus 1. So you add 3y to both sides, so you get 5y. And that gets 0. And then plus 8, so this one's 9. So y is equal to 9 over 5. So the answer is 9 over 5. Number 3, express the following rational number as a reduced common fraction. So this is what I refer to as a repeating decimal, infinite repeating decimal. So first you set the decimal as a variable, so 0.231. Sorry about that. And now you kind of want to move the decimal place over, so then you get the exact same repeating decimal. So I'm gonna you're gonna multiply this by power 10. So like 10, 100, 1,000, 10,000, something, etc. So you're just gonna multiply this by 1,000. Because you want it to move 3 decimal places, okay? So it moves it like 1, 2, 3. So you get 231.231 repeating. You see how that works? Because it's just 231, 231, 231, etc. So it's just gotta be this. So then when you subtract these two numbers together, you get 999x is equal to 231 minus 0 is 231. And then that repeating decimal subtracts each other out, so you get this. And then you have x is equal to 231 divided by 999. So 231, divide that by 3, you have 7. I know it's divisible by 3 because 2 plus 3 plus 1 is a multiple of 3, which is 6. So divide by 3, you get 21, and then you get 21 minus 23 is 2, and then drop that, that's 21. So then this one's 77 over 333. So this is just 7 times 11. So the 333 is not divisible by 11, but is it divisible by 7? 7, 14, 28, 28, and then 53. Nope. So so this is the reduced form basically. 77 over 333. Okay, that's the answer for 3. Question 4. If the legs of a right triangle measures 20 units and 15 units, what is the perimeter of the triangle? So you could use the Pythagorean theorem. So you have a right triangle, right? And you have legs that are 20 and this is 15. So 20 squared plus 15 squared square root. Sorry about that. Squared. So 20 squared is 400. Let me write it a little bit more to right. Okay. 415 squared is 225. So adding that together, that's 625. So square root of 625 is 25. So this thing is 25. So 15 plus 20 plus 25 gives you the perimeter. This is all 3 side lengths add together. So that's 0, that's 1, and you get a perimeter of 60. Okay, that was question 4. Question 5. The probability of an event is 1/4. What are the odds of the event occurring? Okay, so the probability of the event is 1 out of 4, right? So the odds of it occurring is the odds of it occurring versus it not occurring. So it occurs versus not occurs. Since it's 1 out of 3, right? Let's just have like 1, 2, 3, and then in 0 is that, let's say put a circle x x x, right? So out of the 4, only one of them occurs, which is the 0. So the probability the odds of it occurring is 1, 0. So it's one of them out of 3. So the ratio is 1 to 3. If you could just, other than using like shapes, you could just say it's out of 4, right? So just 4 minus 1 is 3, so it's just 1 to 3, because the odds occurring is 1. But I use this way just to show you how it works. Pretty simple question, though. So 5 is 1 to 3. Number 6, solve for pi. S is equal to 2 pi radius squared plus 2 pi radius times height. So you kind of want to distribute the pi out, so S is equal to pi times 2 radius squared plus 2 radius h, right? And then you solve for pi, so you just get pi to one side, so you just have S divided by 2 radius squared plus 2 radius height is equal to pi. So your answer is just basically this. S divided by 2 radius squared plus 2 radius height. Just rearranging variables, not that hard. Number 7, what is the units digit of 3 to the power of 2015 times 6 to the power of 2016? Okay, so you gotta think about this. So let's say you have 3 raised to the power of 1, right? That's 3. 3 raised to the power of 2 is 9, right? So the units digit is 9. 3 raised to the power of 3 is 27, and the units digit of 27 is 7. And 3 raised to the power of 4 is 81, so the units digit is 1. 3 raised to a power of 5 is 243, and the units digit is 3. Right? You see how it's repeating? 3971 is going to be 3. Let's put 6. 3 to the power of 6 is 729. So the ending value, the unit digit is 9. You see how it repeats 3971 39. So the next one is 71 and then 3971. So right, so the pattern goes by 3971. So every single 4. So 2015, right? 2015. So how many like 4s is that? So divide that by 4. That's 5. That's 0, and that's 3. Multiply by 4, you get 2012, right? So 2012, 2015 minus 2012 is 3. So this one is just 2000. This one is just this is just the same thing as saying 503 over 3 and 3/4. So it has 503 multiples of this 4. So it cycles around this 503 times, and it's gonna end at the third number. So the third number is 7, right? So the units digit of this portion is 7. Okay. Now 6. 6 to the power 1 is 6. 6 to the power 2 is 36, which is 6. 6 to the power to 3 is 216, which is power 6. So you see that it's gonna be 6 the entire time. So 6 raised to any power is just 6. So the units digit of the first one is 7. The units digit of the second one is 6. So 7 times 6 is 42. And the units digit of 42 is 2. So the answer is just 2. So you only gotta keep track of the units digit, because the tens digit and the like hundreds digit, thousands digit, 10,000 digits, all those don't matter, because they're not gonna affect that anyway. Because think about this. Let's say you have 12 times 13, right? You're just gonna have 3 times 2 is 6, and that's gonna be your units digit. Because think about it. You have 3 times 2 is 6. That's 3. That's 0. That's 2, and that's 1. You have 156. Do you see how none of these numbers affected the units digit? It's just 3 times 2. Yeah, so that's the general idea. You just gotta keep focusing on the units digit until you like simplify enough for you to get what the overall units digit is. Number 8, if the numerical sum of the edges of a cube is equal to the numerical of its volume, what is the edge length of the cube? So if the numerical value sum of the edges of the cube, a cube has 12 edges. So let's just draw a cube, right? So draw like this. So it has 12 edges, right? So it has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So a cube has 12 edges, right? So the sum of all of edges, let's say its edges is length x. Since it's a square, every single side length has length s. So the sum of all its edges is just 12x, right? And then the numerical sum of the edges is equal to the sum of its volume, to the numerical of its volume. So the volume of a cube is just x cubed, because it's x squared times x, so it's x cubed. So what is the edge length of the cube? So we just have x cubed. Let's subtract 12x to the other side. So 0 is equal to x cubed minus 12x. Distribute out the x. So you have x is equal to x squared minus 12. So when does x is equal to 0? When is x, this side is equal to 0? That's when x is equal to 0, or x squared minus 12 is equal to 0. Since x can't be 0, since it has to be a side length, you have x squared is equal to 12. And then you get square root 12, which is just 2 square root 3. So the answer is just 2 square root 3. Sorry. So that's your answer to question 8. Question 9. If 2 less than twice a number, okay, so let's write that. Let's say your number is x. So 2 less than twice number. So 2x minus 2, so it's 2 less than twice a number, is equals the opposite of the same number, so it's just negative of x. The opposite of x, basically. What is that number? So you add an x to the other side, so you get 3x. Add 2 to the other side, so you get 2. So x is 2 over 3. So number 9 is just 2 over 3. Not that hard. Number 10. If Tim scores a 50% on his first test, how many times must he score 100% in order to bring his average up to 90%? Okay, so it's just the total amount of score over the amount of tests. So his first test is 50, right? So let's say you got 100 like X amount of times, then you just have to add that to the amount. And you have how many tests is just 1, because the first time you took to 50 is 1 test. And you have X amount, which is the X amount is 100. So you equal to and overall that should equal to 90%, which in decimal is 0.9. Okay, so sorry, no, it's 90%, so you put 90, right? So basically, you have, so you basically just multiply 1 plus x times 90, which is just 50 plus 100. X is equal to 90x plus 90. Subtract 90x, that gets 10x. Subtract the 50, so you get 40. So x is equal to 4. So the answer is just 4. Really simple. Okay. Question 11. If the original price of a gallon of gas is increased by 25%, what percent decrease is needed to return to its original value? So if, let's say, original amount is x, right? So if the original price of the gallon is increased by 25%, right? So you have 1 plus 0.25 is 1.25x. So 25% increase is just 1.25 times x. So what percent decrease is needed to return to its original price? So what percent decrease 125, right? Times, let's say a 50% decrease, right? It's just 1 minus 0.5. So 1 minus x, 1 minus y is equal to 1, because you want to get it back to 1, basically. So 1 divided by 1.5. 1.5 is the same thing as 5 over 4, right? So 1 divided by 5 over 4 is the same thing as 1 times 4 over 5. So 1 minus y is equal to 4 over 5, right? So y has to be equal to 1 over 5. So 1 over 5 is 0.2. So that is a 20%, basically. So 11's answer is 20%. Okay. Number 12. If the set 1, 2, A, 3, 5, and 8 has a unique mode, what is the difference between the largest and smallest possible median? Okay. So if it has a unique mode, right? So A has to be either 1, 2, 3, 5, or 8. Because it has a unique mode. Unique mode means there's only one mode. So since they're asking about the largest and smallest possible difference, let's just choose the largest and smallest number. So A is equal to 1 and A is equal to 8. So we have 1, 1, 2, 3, 5, and 8, right? And then you have 1, 2, 3, 5, 8, and 8. So the median thus is for this is 2 and 3. That makes 2.5. And the median for this one is 3 and 5, which makes 4, right? Because it's just add the two numbers and then divide by 2. So 3 plus 2 is 5, divide by 2 is 2.5. And 5 plus 3 is 8, divide by 2 is 4. So the smallest amount is 2.5, and the largest is 4, because the lowest amount of A is 1, and the highest amount of A is 8. So technically, these would be the smallest amounts. The smallest amount and the largest amount. So 4 minus 2.5 is 1.5. So the answer is 1.5. That's the difference between the smallest and the largest and smallest possible median. Question 13. When drawing 2 cards without replacement from a standard 52 card deck, what's the probability of drawing no 8s? So you don't want to draw any 8s, right? So the only things you would draw is 8s. So how many 8s are in a deck? There's 4 8s. So the first time you could get the probability of getting a 8 in your first try is 4. Since there's 4 8s, 52 total cards. And then the next time you only have 3 out of 51 because you already drew 1 from the 52, 1 8 already from the 52. So you have 3 and 51. 4 divided by 52 is 13. That's 1 and 13. 3 divided by 51 is 1 over 17. So that's 1 times 1 is 1. And 13 times 17, 17 and 13 multiply. That's 7, 14, 21. That's 21. So that's 3, that's 5, that's 0, and that's 7, that's 1. So you get 221. Oops. 21. So your answer is 1 over 221. So that's your answer. Okay. Question 14. The least common multiple of 600 and b is 5,400. The greatest common factor of 600 and b is 12. What is b? Okay, so we have 600 and b. The LCM is 5,400. So just have 5,400 divided by 600. That should get you 9. So b is 9. So b should include a 9 times like some kind of 600-ish. So, and the greatest common factor of 600 and b is 12. What is b? Okay, actually ignore this. There's actually a really special property that says if you have number 1, right? Some kind of number times a second number is equal to its GCF times its LCM. So number 1 or number 2 is 600. So 600 times b has to equal to 5,400 times 12, right? So b is equal to 5,400, which is divided by 600, which is just 9. And then 9 times 12. So b has to be equal to 9 times 12, which is basically equal to 108. So your answer is 108. Using our previous example, our previous solution, is you already get 5,400 divided by 600, so b has to equal 9. 600 could be factored out into 10 squared times 6. So that is just 2 squared. That's just 2 times 5 squared. So that's 2 squared times 5 squared times 2 times 3. So that's the same thing as 2 cubed times 3 times 5 squared. Sorry. Right? And you have a 9. So you have 3 squared basically here. So what we basically need is... No, wait, b is not 9. Because we have 2 to the 3 times 5 squared. And basically we need 9. So we need the LCM is 2 to the 3 times 3 squared times 5 squared. Wait, 3 to the cube, right? Because you need 3 squared more. So basically the other side has to have a 3 squared. And it might have a 5 and it might have a 2. But both of these numbers has to be... the 2 has to be less than 3. This side actually has to be 5 to the 3. Because this is 5 to the 3, right? So this one has to at least have B has to at least be 3 to 3, and this side has to be less than or equal to 2 to the power of 3, or so it's less than or equal to 3, and this has to be less than or equal to 2, basically. So the greatest common factor of 600 and B is 12. So the greatest common factor, since they already have a 3 together, that means they need a 4 together. So this has to be 2 to 2, basically. Then that's 3 to 3. Since they don't have 5 anywhere, B has to be 2 to 2 times 3 to 3. So 3 to 3 is 9, 27, and then 27, and then 2 to 2 is 4. So 27 times 4 is 108. And that's another way to think about it. Question 15. What is the 14th digit to the right of the decimal point of 1 divided by 98? This is just a really much trial and error. I can't really think of a faster way to do this. So let's put 1 here. So 1 divided by 98, you can't put it, so that drops another 0. You can't do this either, put another 0. You put this as 1, so that's 98. As that, it's 2, 0. Drop down 0, 0. Put down there 0, that's 2. That's 196. That makes a 4. Drop down a 0, so that's 0. Drop down there 0, that's 4. So 98 times 4 is, it's just 2 of this one, so that's 392. Right, subtract that out, you get 8. And you drop down 0, so it's 0. Drop down 0, you put an 8. So 98 times 8, so 184. That's what it subtracts up to. So you have a 16. 16, let's just write it up here. I need room. So drop down that 0, you put this as 1. So minus a 98, that's 2, that's 62, right? So you have 62, drop down that 0. 620 divided by 98. What number could that be? 5, nope, 6. So put 6 in here. 98 times 6 is, that's 48. So that's a 4, that's 54, 58. Yeah, 588. So you put a 12 minus, that's a 12, and that's 32, so that's 320. Grab 0. So you have to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you need to do this 4 more times. So 320 divided by 98. We could do this 3 more. This is 3. So 98 times 3, 294. Track that, that's 6, and that's 26. And you drop down a 0. Okay. That's 100. So you could probably put this twice, and that's 260. Let's just put it back up here. And then times 2, we already have it, that's 196. That's 4, and that's 64. So drop down to 0. 640 divided by 98. That's probably gonna be a 6. So that's it's just because I'm thinking about it, it's just 100 times 6 is 60, but since it's less than, it's just gotta be less than 640. So that makes 600, so that's 2 less than 100. So minus 12 from 200, so you have 588, right? And you subtract that, so that gets 12, and that's 52. So 520, so yeah, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 520 divided by 98, the highest number is 5, so the 14th digit is 5. Okay, just pretty tedious, but at least it didn't ask for like the 100th digit, so that's good. Question 15. A spinner has a 1/3 probability of landing on a 0 and 2/3 probability of landing on a 1. So 1/3 probability of landing on a 0 and 2/3 probability of landing on 1. The results of multiple spins are added together. If the spinner is spun twice, what's the probability that the sum is exactly 1? So the sum is exactly 1 if it's 0, 1 or 1, 0. So 0, 1 is 1/3 times 2/3, or it could be 2/3 times 1/3, right? So the probability of this occurring is 2/9, and the probability of this occurring is 2/9. So adding them together, the overall probability is 4/9. So the answer to question 16 is 4/9. Okay. Question 17. Given a, let me move this up. Given a positive integer n, the unit fraction of 1 over n can be written as a sum of two other fractions. 1 over n equals to 1 over a plus 1 over b. If n is equal to 2, determine the all coordinate pair a and b where a and b are integers satisfy the equation. So you have 1 over 2 is equal to 1 over a plus 1 over b, right? Let's simplify this into one thing. So you have 1/2 is equal to, multiply this by b, multiply this by a, so you have a over b, and a plus b over ab. So, we have the same, so a plus b must equal 1, and let's just cross multiply it. So you have AB is equal to 2A plus 2B, right? So let's get all this variable to one side. Let's just get A. So AB minus 2A is equal to 2B. Distribute out the A and divide by it. So A times B minus 2 in parentheses equals like 2B. So divide by the thing to the other side. So you have A is equal to 2B over B minus 2, right? So, we want a to be an integer. So, what coordinate pairs does that work? So if we have, let's just start with 0 and start working away. So we have 0 for b. Sorry, we gotta put on the other side. Then a could be then a is equal to 0, which doesn't work because a and b has to be because 1 over a plus 1 over b is would be undefined. So 0, 0 doesn't work as a solution. Let's say b is equal to 1, right? That means a is equal to, plugging that in, that's 2 divided by -1. So that's -2, so a is -2. So that's -1/2, and that's 1, so that's, yeah, 1/2. So that works. If we say b is 3, right? If b is 3, that makes 1, and that's 6. So that's 6 and 3. So 1/6 plus 1/3. So that'll be 2/6 over 1/3. So that's 3 over 6. So that's 1/2. Yeah, that works. So if we put 4, right, that makes this 2, so that divides that 2 out, and then we have 4 here, right? So we have 4, 4. Can we put 5? 5 doesn't work. Can we put 6? If we put 6 here at B, that makes a 4. Yep, 6 works. So we'll put 6. We have minus that to 4 all over, wait. So 6, 6 divided by 4 would be, wait, that's 12 divided by 4, which is 3. So we have 3. Okay. So we have -2, 6, 4, 3. Okay. Because after this, I guess it doesn't work anymore. Because, like, if you think about it, you have as b approaches like some big number, right? Then it's gotta be 2b over b minus 2. Then it's got, as it approaches infinity, then it's just gotta be 2b over b. So a will reach 2, but it's never gonna reach 2, right? So basically, 3 is gonna be the biggest amount because it's getting smaller. You see how it's decreasing, and it seems like it's going to 2, so it's not gonna go to 2. So it's gonna end there. So we have 1, 2, so we can't use 0. Let's start using negative. So we put -1. That is -3. Nope, that doesn't work. Let's put -2. If we put -2, that's -4, and that's -4. So that's 1. So it's 1, -2. Yep, that works. And then let's put -3. That doesn't work. A -4. That makes -6. Nope. Um, negative 5, no, negative 6, that makes negative 8. That does not work. So, negative 7, no, negative 8, no. So, since a bunch of them are going to no's, I'm guessing that these are all the possible points because you don't want to test them all out and waste time. So the answer is negative 2, 1, 6, 3, 4, 4, 3, 6, and 1, negative 2. So so these are the 5 possible solutions. So you just put all these ones down, which is probably the answer. Okay, and number 18. If the circumference of some circle with radius r is increased by 6 pi, okay, by how many units is the circle's area increased? So let's say our circumference is 2 pi radius, right? So basically that's our uh circumference. So what they're doing from that circumference is that they're adding 6 pi. So the circumference is adding by 6 pi. But so that's the original radius, radius 1. So now we have to find a new radius. So now we have 2 pi radius squared. 2 pi radius subscript 2. So that's the new radius. So basically, we're going to see what's the relation between the original and the new one. So if we're adding them together, we have pi 2 radius 1 plus 6 is equal to pi 2 radius squared. So I'm just moving the pi away. So you just divide that pi out. And then divide by 2. So you get a radius subscript 1 plus 3 is equal to radius 2. So the new radius is just 3 more than the old one. So how many units is the circle increased? So basically this is our original radius. So our old circle with radius or subscript 1, the area is pi radius squared, right? So radius 1 squared. And now we just have, now the new area is pi radius 2 squared. So substitute that back in, you have pi radius 1 plus 3 squared. So that's just 1 squared, subscript 1 squared, plus 2r 2r1 plus, wait, no, plus 6r1 plus 9. So basically, if you kind of distribute that out, you gotta have pi times radius subscript 1 squared, which is the original one, plus 6 pi radius 1 plus 9 pi. So it's 9 pi plus 6 pi radius 1. So 6 pi radius 1 basically is what is, how many units is the thing increase is increased by this much. 6 pi radius 1, or just write radius because they didn't specify. They just said radius. Don't write radius 1 because that's what we denote it as. So put 6 pi radius plus 9 pi. So that's the answer. It's not gonna be a numerical because if you change the radius, like the circumference kind of changes and the area changes. So it's gonna have a variable. Number 19. In the decimal expansion of 23 factorial, what is the first non-zero digit to the left of the decimal point? So um basically what you do is the first non-zero digit. You kind of look for the smallest value. So how does this work? To the non-zero. Okay. So we have 23 factorial. How many 2's do we have? And how many 5's do we have? So if we have 23, right? Let's think about it. Because we want to take out all the 2's and then we want to take out all the 3's. Let's just write all the numbers out because that's probably the only way that I could think of. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 17, 18, 19, 20, 21, 22, and 23. Okay. So I know 5 and 2 makes a 10, so that just makes a 0. Take away a bunch of 10s out. So 5 and 2 makes 10, and that makes 10. The 1 doesn't do anything, so cross that one out. So we just need to take away 5s and 2s. So take away the 10 here, that makes a 2. Take away 5 here, that makes a 3. With that, 2 makes away basically another 10. So any more 5s in here? 5, 10, 15, 20s, okay? So we basically have a 3 times 4. So let's kind of just multiply this out because we only want the units digit. So 3 times 4 is 2. So 3 times 4 is 12. So the units digit is 2. So just cross those out. 6 times 7 is 42. So that makes another unit digit 2. Cross those out. 8 times 7 is 8 times 9 is 72. So just put another 2 and cross those out. But you're just only gonna focus on the units digit, and that's all that matters. 11 times 12 is 132. So that cross this out. That makes another 2. 13 times 14 that makes a unit digit of 2. A lot of these are units digit 2, I guess. So 3 times 16 is 48. Okay, so the units digit here is 8. 17 times 18, that's 7 times 8 is 56. So the units digit is 6 here. 19 times 21, unit digit is 9. And 22 times 23, unit digit is 6. Okay, so 2 times 2 times 2 is 8. So cross that out, that's 8. 2 times 2 times 8 is 32. So the units digit of that is 2. So we're just gonna only focus on units digits now. So only like 1 digits or like units. So 6 times 9 is 54. So that's a 4. Units digit 4, and then you just have remaining 6 level from here. So 8 times 2 is 16. So you have a 6. And 4 times 2 is 24. So you have a 4. So 6 times 4 is the last over. You get a units digit of 4. So 19 is just 4. So it's kind of tedious, but it kind of simplifies. Like it gets the first process by taking all the tens away, which is just 5 times 2. So take away all the 5s and 2s. The same amount of 5s too. So you take away 1 5 and 1 2, 2 5s, 2 2s, 3 5, 2 2s, 3 5s, 3 2s, you know. So you take the same amount. So then they multiply by 10, and then you take out all the zeros. So those take out all the zeros, and then you multiply the other rest of the numbers and gets units digit and multiply all. You're only gonna focus on the unit digit and just simplify it to the unit digit, and you get the answer. So the answer is just 4. It's kind of tedious, but since you don't have a calculator, if you had a calculator, this would be easier. But if you have just by hand, this is the process that you would do it. 20. On the grid below, how many paths lead from A to B? Okay, so A to B. If you're only going rightward, so you're going right this way, and moving upward along the edges. So only right and above. So just kind of draw a picture out for this. I might be very bad at this. So you have 4 blocks. So 1, 2, 3, 4. And then we put 3 more blocks. 1, 2, 3. And then another block right here. But basically right here and here. This one's missing. And then you put another 4 blocks. Okay. And you put 2 blocks in a 1. So what you do is that you kind of just count. Oh, sorry, that looks kind of bad. Right. So what you kind of do is just you count. So how many ways can you go from A and B, right? So how many ways can you go from here to here, which is 1, and this is 1. And how many ways can you go from here to here, which is also 1, right? Because you only could go one way. You can't go like this and go back down because you're only going to the right or going up. So only what? 1 here, 1 here, 1 here, 1 here. So all the side is 1, basically, if you think about it. Because there's only one way to get there. So those points, those intersections, right? So you're gonna count the intersections. So how many ways can you get to this current point? There's one here and one here, so there's 2 ways here. And then how many ways can you get to here? There's 2 ways here, and there's 1 way here, so that adds up to 3. Right? You see how this pattern goes? So you have for a way here, because you can't go down. Once you go up, you can't do anything here. So this way, you're not gonna go anywhere. So once you stop here, it's 4. So you can't add down and make 5. You know, it's not gonna work because you can't go down because you can only go up and you can only go right. So you have a 4 here. So you have 1 here. So 2 here. That makes 3. That 3 plus that 3 is 6. And that's 6 plus 4, and that makes 10 right here. So you have 10 ways to get up here. So the only way that you could go up here is getting 10. Because there's only 10 ways. You only could go here. You can't go like here and then go back, because then you're going to the left when you only could go right and up. So right here, that makes a 4. Because 1 here and 3 here makes a 4. There's no way to get out here because the bridge is broken. So technically there's only 4 ways to go up here. There's 5 ways to get up here because there's 1 and there's 1 and 5, right? And there's 6 ways to get here, but it stops right here because once you go here, you have to go back, which you can't. So this is gonna be another dead end, so we don't need to worry about that. So we have a 5 here and we have a 4 here. That means we have 9 ways to get here, right? Oh, sorry. Right? You have 9 ways to get here. And since the only way to get here is through this way is also 9. Okay. So, and this way to get to this way is oh wait, sorry. You have 4 ways to get here. And how many ways can you get here? That's 4 here and 10 here. So you have 14 ways to get here. And 14 ways to get here. You have 10 ways to get here. So you have 24 ways. So 14 times plus 10 is 24. And you have 14 ways to get here. You have 9 and 14, so that gets 23. And then 23 and 24, that makes 47. And that 9 and that 23 here together makes 32. So 30 to get to A to B, you just have 47 ways here and 32 ways here. So you have 79 ways basically in total. Because 47 plus 32 is 79. So that's basically what you do. You kind of just like add like a number of paths and just focus each individual point when you go up there. Fun fact, basically if you kind of look at the rows, it kind of looks like the Fibonacci. But since it's not a complete like perfect square that looks like this, if it's like this, it's gonna be a it's gonna look exactly like the Fibonacci, but since there's like things are away, there's not. So you kind of look diagonally. You have 1 1, 1 2 1, 1 3 3 1, 1 4 6 4 1, right? But then you have all these random numbers. So it's supposed to be like a 10 10 5 1 10 10 and that 1 5 10 10 5 1, right? But it doesn't show that because it's not gonna because it has those broken squares as I said before. So so this thing is kind of incomplete, but that's basically how you do it. If it was complete, you could probably just think of it the Fibonacci and just go up. So that basically completes the CCML Algebra 1 Contest 1 2015-2016 Division A. Thanks for watching, and I'll see you at the next math record.